Okay, great. We're going to move on to the next session now. Tony Van Eerd is going to be telling us about value-oriented programming. Hey, Tony, welcome.
Hi, Sai. Always wanted to say that. Do you want to talk about purple dragons? I bet you do. All right. I'm Tony Van Eerd. I work at Christie Digital. I want to talk about objects and values, which is a very simple topic. And because it's such a simple topic, it takes hours and hours to explain because the simplest concepts are always the hardest to explain. So I'm not going to try to explain it all. I'm just going to do a crash course. Right? There's too much to explain everything, but we'll do a little crash course. I'm on the C++ committee. Some of my papers worked on things like optional and variant, some little bits of concepts. Like to complain about naming a lot. The yellow papers are successful papers I've written. But if you're only going to read one paper, read the two pink ones. Those are my favorite. And my other, I like to claim to fame here is Herb Sutter said my code is righteous. Let's not worry about what the context was. Let's just assume he meant all my code, ever, future, whatever. But what I do is projection mapping, right? So, which is working with projectors, projecting something that basically texture mapping objects in the real world, not inside the computer. So that is not really a purple dragon. I can't even see myself. How's my video? All right, there, yep. It's a gray model. It's not really a dragon either, it's a model. And it's not even on the table right now. But that is a table in the picture, so it is one out of three is true. It's a video of a presentation of a picture of a table, and then it's a fake dragon, and the dragon's not purple. But let's pretend that it's a purple dragon, and you can see that it's on the table. So the word the is taking up doing a lot of work there. It's not a dragon, not just any dragon, it's the purple dragon. It's on the table. We could spend all our time talking about the word the, but Bertrand Russell did that over 100 years ago. Go read all he's got chapters on the word the and another chapter on the word a. So we can leave that to Bertrand Russell. How about is on, and purple dragon is on the table. We basically have three things there: values like purple, objects like the dragon and the table, and relations between them like is on. And in philosophy, people like to, should I have warned people philosophy is going to show up? Sorry. They usually talk about properties or attributes instead of, in programming, I like to call them values. And philosophers often want to eliminate at least one of these categories because wouldn't the world be simpler if you only had two categories or one category? So you can kind of say like all properties, like purple is not a property, it's just an object, but it's an abstract object. It's the color purple, the abstraction of purple. And then you could say the dragon being purple isn't an attribute, it's just a relation between the dragon and purple. Or you can make properties into relations. You can try making any one of these. I had a prof who tried to make he made everything relations. He got rid of the other two. People usually keep objects or values. He just got rid of relations, or got rid of everything and only kept relations. And if you start out with the identity relation, the relates to self, which is literally the relation relates to the relation. So because it needs nothing else, it can just pop itself into existence. And then from there, you can build the whole universe, right? because then you just make more and more relations that relate to other relations, and you get a universe out of that. At least one prof thought so. So we could concentrate on relations like is on, and go down that route. But there's actually a more modern philosopher, Sean Parent. He's talked about relations recently. So we can let him handle that part. We'll talk a bit about relations, but we'll let Sean do most of that part. So that leaves us with values and objects. And just to ease your fears that it's all going to be philosophy, there's some code, right? So it's pretty much, that's surprisingly close to how philosophers and programmers think the same of, a dragon is an object, like a class. It has some properties, some attributes or values like color. Now, of course, color could also be a class. So then you might think, is color also an object, or is color somehow a different type of class? Then it's very value-ish. And that's the part we want to try to figure out, when are classes more object-y and when are they more value-y? And what do we mean by values and objects? And because this is a crash course, I'm just going to throw out some examples so you can get a feel for the idea. Because I'm kind of using object not necessarily the way it's always used, not the way the standard use it, because the standard, every blob of memory is almost an object. Every variable is an object. Object-oriented programming kind of tends to mean something different than the standard. So, a button or a projector. Projectors, I work with projectors. They're big physical objects. The ones we have are like the size of a refrigerator. They're objects. They're literally, real world objects. And then we will, in our code base, we have a C++ object that represents that projector. A button is almost a physical object, like a UI button. It might as well be physical. You click on them and tap on your phone or whatever. Slides in a slideshow, kind of object-y. But something like an int is the canonical example of a value, or a string, even though it's a class, or a point class that might have X, Y, Z in it. They're objects in that sense, but we tend to treat them like values, right? Or color. Color is a value. So that's kind of what I mean. And objects tend to be not copyable. I would love to be able to make a new projector just by copying it in memory on my computer, but no, they're very expensive things. You come out of a real physical factory. If you passed a button by value to a function, would you want two buttons to show up in your UI? Right? I don't think buttons usually are passed by value. A lot of things that you don't want to be copying. It's objects. And typically, if you have objects in a hierarchy, in an object-oriented hierarchy, you're not making copies. Sometimes, but not usually. Whereas values tend to be copyable or movable as an optimization of copyable, basically, typically. Like int, it is the de facto standard value. And objects are changeable. Right? Observable, they have lifetime. The button is checked. Now it's not checked. The dragon was purple. I can make the dragon blue. I can make the dragon red. The dragon changes over time. Whereas values, in some sense, are immutable, right? The number 17 is, going back to the, Bertrand Russell, is the number 17. It's not a number 17. It's the number 17. Because it's always the number 17. You can count on it. It's a number, you can count on it. So it's always forever 17, never changes, right? Your variable, your int, can have a new value in it, but you tend not to care about that. You care about the value inside the int, and the value itself is immutable thing in the conceptually immutable thing. The number 17 is immutable. And then I like to call them both timeless and ephemeral. Timeless in the sense that 17 is always 17 forever, but ephemeral in that your values in your program tend to come and go, right? And an integer comes into a function and it leaves, and you're not. It's not necessarily a state you're tracking everywhere. It's just a temporary value. More often, if you take an int and make it a global variable, then well, okay, now things are different. But typically, they're very ephemeral. And objects are the ones that get to have relationships, right? The dragon is on the table, like that. And buttons are, the child of a window. And these are dynamic relationships that can change. I can take the dragon off the table. And the button can move around and not be on the window anymore and things like that. Values also have relations, but that's more mathematical, and it's static relations. Like 17 is less than 23. Always. Once again, you can count on it. But we can do other things that with values, like make pure functions that, or like Stepanov likes to call them regular functions, that take values and return answers, and we tend to use functions more than relations on values. And of course, if you're thinking languages, Java is the classic example of an object-oriented language. There's many others. I like to think that C++ is a value-oriented language. And, there's a million other functional languages out there that are more value-oriented. But C++ is multi-paradigm. It can be an object-oriented language, but it's in some sense fundamentally value-oriented. You get a default copy constructor when you make a class. It's like, yeah, of course you want to copy things. Of course you want to, like, C++ tries to, by default, make your class work like int. If you don't do things to make it not that way, it's going to work like int and be very value semantic. And then similar, the STL, because of Stepanov, is very value semantic. Vector, even though it holds a bunch of values and feels like a big object or something, vector acts semantically like a value. You can copy it around. Equal on a vector checks the value of the elements of the vector, right? Are the values held by this? Everything held by the vector is the value of the vector, and equal checks that, right? And in object-oriented programming and stuff like that, it's like, and I once had to teach a bunch of Java programmers, refresh their C++, and they were all worried about pointers and tracking memory and all that kind of stuff. And I found it really odd because, there's pointers all over Java. There's called references, and sure, you don't have to worry about the lifetime, but you still have to worry about where they're going and who's sharing them and all the relationships between things. So, but they were all like, oh no, pointers. And then over here in the value land in C++, you can be, oh, no pointers. Like if you treat your, vector holds a pointer inside of it, you never have to see it. You can just treat it like a value. All right, I don't know how well you guys are hearing the audio, but he obviously said copy or copy not. There is no shallow. Kind of as an example, that's just what I was mentioning about vector there, and versus the oh no pointers, right? When you have a class, whether it's a vector or some other class where you have a pointer inside your class, if you make a copy of that class, by default, you're going to get this, and you're going to have to worry about what to do with the pointers. And as we all know, you probably want to do this and make your two objects distinct from each other and not share the data, because you don't want shallow copy. There is copy or copy not. There is no shallow. Trust me on that one. And Master Yoda said that, and Master Stepanov pretty much said the same thing. This is the definition of regular, of like a regular type. A regular type is basically one that acts like int. When you assign it or make a copy, the copies are equal. The important one there is that if you make A and B equal to C and all three are equal, and then you change A, well, B and C are still equal, but A is no longer B because you changed A and it's distinct from B. There's no, there's no parts being shared. It's separate. And that's just an important part of being a value, is being a distinct value. One value, 17 and 23 aren't going to mess with each other. All right, where do I go? Oh yeah. So back to this. The real difference on the left from the right is that objects have identity, right? It's like this object, this dragon, the dragon right here. Whereas values, you tend not to care about the identity. Sure, you have variables, but an int that's flowing through a function, you care about the value inside the int. You don't care about the variable. If you take an int and you make it a global variable, suddenly it has an identity, right? Its address is important. And it's the identity that allows, by having identity, you allow yourself to have, it changes over time because it has an identity and it's observable. You can be like, I'm talking about this global integer, or I'm talking about this object that has an identity. And you can have relationships, just like this object and that object. If I can't identify it, it's hard to keep relationships between them. And the real, philosophical way of thinking about this is the good old Ship of Theseus. Anyone? Everyone knows Ship of Theseus. It is basically this is a it's not just a, everyone uses it as a logic problem or a paradox or whatever, but it really was a ship that they were keeping intact and restoring constantly, right? If a piece of the ship needed to be replaced, it was replaced, and then the next piece was replaced, and the next piece was replaced, to the point of there's no original ship left. It's all been replaced. And then the question is it still the same ship, right? And to a certain extent, I think this is objects versus values, right? It's like, do I care if it's the same ship? I just care about the value of the ship. I just need something that floats or something. Or I need to know the value of the ship, or I need the identity of the ship because Cy and I have decided that we're going to meet on the Ship of Theseus. So like we need to meet at the same ship because we want that relation with I am on that ship kind of thing. And the other question about the Ship of Theseus is, if we take all the wood that we replaced and build another ship out of it, which one's the Ship of Theseus? The one that we kind of labeled the Ship of Theseus, we've given it that identity and we've tracked it, or the one that we've used the original wood? It always gets the old wood, so it's kind of the original ship. And then the other question is, do we care, or do we only care about the value of the ship? And it, like all questions in C++, it depends. And that leads to this. There's a good talk by Rich Hickey called The Value of Values. You should watch it. Not right now, but should go watch it. And he calls it place-oriented programming, PLOP, because the identity in object-oriented programming is the address, right? The reference, the pointer, the address of the object. And it's like, we're talking about the dragon at this memory address, right? Place forms the identity. And I think he kind of purposely gave it the name plop because it doesn't sound great. But that's basically what most of our coding is like. It's place-oriented programming where we're tracking the state of the world in a place in memory, which, that is what programming is kind of about. That's what computers do. But let's see what some other philosopher had to say about it. Right? He said, state leads to suffering, right? If you get the extended cut of Star Wars, you see the full quote. State leads to objects, objects lead to references, references lead to sharing, sharing leads to entanglement, entanglement leads to suffering, right? So, state is hard to avoid. That's what computers do, but it's how we try to manage that state. As soon as you start having objects and relationships between the objects, you have to remember, like, Jedis weren't supposed to have relationships. Anakin, Padme, get entanglement and leads to suffering. It's a path to the dark side. Similarly, another philosopher, Sean Parent, likes to talk about incidental data structures. And imagine you have this. There's a billion examples of this, but say you just have like a contact app on your phone, right? So you've got a class called contact, and maybe it has points to another object called location, and they're, maybe you would do this as just a member object, but maybe it's a separate class and you have a pointer to it for some reason. And then that forms a data structure, right? And then you can have another contact, and it's, another instance of your data structure. But if you ever end up doing, a shallow copy, or for some reason these two people share an address, the two contacts, live at the same location, you might end up sharing a location. And whenever you have pointers crossing between objects like this, this is not two data structures. This is one data structure, right? Sean likes to call it an incidental data structure. It's not the data structure you thought you were making, but it's in your code, and you really see this everywhere. Almost every use of shared pointer, you're forming an incidental data structure. You might think, oh, I've got a window and it's got a pointer to a camera or a projector or whatever, and these are separate objects. But as soon as you are pointing to each other, you're building a data structure, and it's probably not a well-defined data structure. You've just got random bits of code that has to know what the rules are. Oh, do I own this object? Can I do this? Can I move it right now? Can I do this to it right now? There's a data structure hiding in there, but you've spread it out throughout your code. Yeah, I really think almost all code looks like this. Everyone's code base is full of incidental data structures. And, Yoda's trying to convince us not to entangle it, and Palpatine's just going the other way. I'm pretty sure that's what he says, right? I am the state. Yeah, I think that's it. So how, what are we going to do about this entanglement? If we go back to, objects versus values, maybe we should talk a little bit about math and regular functions and stuff. So I did a talk earlier this year and last year on the same idea of value-oriented programming, but more focused on functions. And by the way, I like to call it value-oriented programming. It's going to catch on. Like, I like to think I'm the first person who used this term, but I found a paper just the other day from 1981 that used the term value-oriented programming. It's a good paper, actually. You should read it. Not right now. But some people call it just value semantics or whatever, but it's very much values, when can we be more value-like instead of object-like? So value-oriented programming. Here's some functions, right? Kind of when you think of functions, you think of one of these mental models, and you might even wonder, like, what's the difference between these two models? If you don't know Dr. Seuss, you might not recognize the one on the left. It's the putting stars on your sneeches. So the one on the left takes an input and modifies the input and produces an output. The output is the input, and it's just modified something. It probably took something in as a pointer and modified it directly. Whereas the mathematical world, you might take 17 as an input and produce 23 as an output, but you didn't change 17 or 23, right? And this is my favorite quote nowadays. It's not an exact quote, actually. I've kind of paraphrased it, but it's a good book by Eric Norman called Grokking Simplicity. You should read it, not right now. And one of the fundamental concepts is separating calculating from doing. And what do I even mean by that? So let me kind of explain that. If we are going to put stars on sneeches, because, who wouldn't want to do that? You can think of the function that does this. You notice it takes a sneech by reference, non-const, returns void. So it's very much modifying its input directly. I think functions that return void are something to be worried about. Not always, but often. But anyhow, a star on function would probably measure the sneech, find the belly, calculate star positions, and then apply the stars to the sneech, right? Everyone knows how to put stars on sneeches, I assume. And three of those things are calculating, and only one of those is doing something. It's only one is affecting the state of your program. The first three can be done in a function that doesn't change anything. It takes values and returns an answer. In fact, you probably wouldn't take the whole sneech. You would probably take some representation of the geometry of the sneech. And you either take that as a const ref or whatever, right? It's like you're basically treating the geometry as a value. You're calculating a star position, and then sure, apply stars is a valid void function that changes the sneech directly. But you've separated your code into, let's say 3/4 of it is now calculating, and only one part does as it probably turns out, the calculate the star position is probably a lot harder than applying the star, right? It's usually applying the star is write your values into your document or something like that. And you can imagine that one of these functions is a lot easier to test, right? Calculating star position, you can test in isolation. You can understand it in isolation. You don't have to understand the whole program. Actually applying stars, modifying the sneech, worrying about, what the sneech being an object, what relations are going on between the sneeches and all this kind of stuff. So it would be nice to have more pure functions, right? Same input gives the same output and no side effects. Minimize your side effects. That's the doing part, and separate calculating from doing. And all the calculating part is basically functional, is basically value semantics and local reasoning. You can, it's a lot easier to think about a function that doesn't touch anything outside its inputs. And you don't have to understand the whole program if you don't have to worry about all the entanglements. So I have one question I know people are supposed to ask me questions, but instead I'm going to ask questions. The Queen of Clubs. Is the Queen of Clubs an object or a value? So my kids are always like, why don't you ever write a game? Right? I'm a programmer. I don't really write code at home. And they're like, why don't you write a game? So I started writing a card game. And of course it was like command line card game. And of course I spent all my time writing the library that's going to be like, I could write with this library, I could write any card game. And I'm like working on the class for card. And it's pretty simple. It's got a rank, a suit, and then it's like, oh, should it have a copy constructor? Like, should you be able to copy the Queen of Clubs? Is the Queen of Clubs the Queen of Clubs? Is the Queen of Clubs an object, or is it just about like it's? I mean, the rank of the Queen is the rank and the suit are just two ints or something, or two enums. They feel very value-ish to me, but the Queen of Clubs, is it a value? Is it an object? Is it sometimes both? Should I have the card object class and the card value class somehow? And then what's the relation to the, like, is the Queen of Clubs a object because it's in your hand and then it's played on the table and then it's, moved around. And the real worry was like, I don't want to suddenly have two Queen of Clubs, in my game accidentally. That's why I didn't want to copy. Now we have move semantics that could also help here, so that just make it move only. But I was stuck. This is why I didn't finish the game. I was like, I really should figure out if this is an object or a value. And then someone spilled water on my laptop and I lost it all. So I'm getting right near the end here. Here's my, thoughts on, I'm not even sure what this means, but, something, objects aren't everything. So, Sai or anyone else, do you have any questions about the purple dragon that's on the table, which is really not purple, nor a dragon, nor on the table?
Well, thanks very much for that talk. And if folks have any questions, please drop them in the chat on the Visual Studio YouTube channel. We've got a couple of minutes until our next session. And I would very highly recommend going watching the Tony's talk, which you mentioned on calling functions. I find myself now thinking about that when I'm writing code and thinking, which function would I like to exist at this point while I'm writing my program? And then I just
write the functions you want to see in the world. Write the functions you want to see in the world.
It's a great talk. Any questions for Tony?
I have a feeling I went fast. Sorry if I went fast.
Oh no, you're actually about perfect.
Classically, also, I never know how long my talks are going to be because I don't time them.
Yeah, I remember I gave a talk at ACCU once on explaining Hello World in C++, and we overran our 90-minute time slot because Hello World is just too complicated for 90 minutes.
Definitely.
All right, well, K-Music says it's superbly explained. Milos says, how do you feel about functional programming, Tony?
Oh, I mean, I kind of love it. I just, it's not going to, for some reason, it's not taking off completely. It seems like we're not going to write it's out there. People are doing it. People are writing real software with it, but it's not the predominant way of writing code. And there's probably reasons for that. So all I'm trying to do is make my code functional where it can be, right? Fundamentally, I think I use projectors and cameras, right? Fundamentally, they are objects. I think objects is correct for them. And I use different types of cameras, different types of projectors. So they are fully polymorphic, the whole thing. Now you can do polymorphism in value-ish ways, like using variant and things like that. But these are just classic, object-oriented things. But it's really that idea of splitting off. And I see it, you see it all the time where I have giant functions and it does a whole bunch of work. And the last line of the function is, okay, now set the answer into the member variable. And I was like, wow, all this other stuff was just calculating stuff. And that could have been split off. And then, you know, you don't, there's secondary problems going on here of, I like to say classes are made of Velcro, right? You got a class like camera class that just keeps getting added more camera stuff to it. And you put all the, also, you know, I'm not a big fan of member functions. You keep adding more and more to that class because, oh, it's camera stuff. And so much of it could have been split off to just be a free function that just, you know, sure, the camera takes an image, but all the image processing is in a free function or things like that. Like, auto exposure and things like that can all be separated off, and be very functional. And then you do the objecty stuff for the objects. Val is a experimental language going on right now that's trying to get the best of both worlds. They allow modification of objects. Like functional programming, you never modify anything, right? Everything's immutable. Val is in-place modification, but still very functional. You know, hand wavy.
Yep.
And, you know, you can either try to find a language that does that or just, I like C++. I'll just use, you know, I think C++ is a functional language trying to get out of, you know, whatever. There's that saying, it's a small language hiding inside the big language. There's a small functional language hiding inside of C++.
For sure, yeah. All right, well, thank you so much for joining us, Tony. And we'll head over to the next talk.